Hey everyone, hope you're doing well today. In this video, let's go ahead and talk about some linear equations. And hey everyone, hope you're doing well today. In this video, let's talk about some linear equations. More specifically, a little bit more challenging ones for pre-algebra, or maybe if you're learning about linear equations in Algebra 1. Okay, so let's go ahead and try some practice problems together. So for this first one here, let's go ahead and take a look at this equation where we have y minus 11 is equal to 0. So to go ahead and deal with this one, what you're going to do is just add 11 to both sides of this equation. If you go ahead and do that, then our equation is just going to say y is equal to 11. And whenever you have an equation that just says y is equal to a constant, you know that this is going to be a horizontal line. Okay, that's always going to be the case. And let's go ahead and identify maybe the slope as well as the y-intercept for this equation. So for the slope, that's going to be m. M is always going to equal 0 for a horizontal line. And for the y-intercept for this horizontal line, that's just going to be located at 0, 11. So let's take a look at that in just a moment. But we know that this is a horizontal line and it's crossing the y-axis at 11. So if we were looking at this on a graph, maybe like this, let's say like every box here is worth maybe 2. So 2, 4, 6, 8, 10, and 11 would be like right here, right? So if I already said that this is a horizontal line, rough sketch here, but this is what this graph would look like going across, okay? So that's number one. Let's go ahead and try another one here. So for number 2, let's check out another equation. Let's do x plus 5 is equal to 1, okay? And if you want to go ahead and solve this equation so that we can understand it just a little better here, we can take away 5 from both sides and say that, okay, x is equal to negative 4. And so if you have an equation that looks like this, you want to know in the future that it's always identified as a vertical line. So the slope is undefined, okay? That's undefined. And what is the y-intercept? Well, this one actually isn't going to have one. Okay, I'm going to say none here. And you may be a little confused by that now, but let me try to show you graphically what that looks like. So maybe, can I fit this in here? I'm not sure. Let's move everything over so I have a little bit more space. I think I can fit this next to it. All right, cool. So where is x equal to negative 4? Let's say every box is worth 1. So 1, 2, 3, 4. This is where x is equal to negative 4 always and forever. So real rough sketch here. This is that vertical line at x equals negative 4. So notice it doesn't cross the y-axis at all, so it doesn't have a y-intercept. All right, so for number 3, let's try another one here. Let's try negative x minus y minus 13 is equal to 0. We want to put this so that y is isolated, that dependent variable. So we're going to go ahead and add y to both sides of the equation here. So y will be by itself. We'll have negative x minus 13 is equal to y. And you can turn this around and say y is equal to negative x minus 13. Okay. If that's the case, what can we find out about this? Well, the slope here is going to be the coefficient for x, which is negative 1. And for the y-intercept, that's just going to be located at 0, negative 13. Again, that's the constant value, okay? Over here, let's go ahead and take a look at a graph. What would this look like? So if I say every box is worth 2 here, then if we go down 2, 4, 6, 8, 10, 12, so negative 13 would be halfway right over here. And the slope is going to be negative 1. So it's going to be down 1 over 1, down 1 over 1, down 1 over 1. And so if you made a rough sketch of this graph, it would look something like this. And it's going down, okay, to the right. So that would be this equation for number 3. Okay, that would be the graph. For a fourth one here, let's go ahead and check out this equation. Let's try 7y minus 4x is equal to 4. We can go ahead and try and solve for y just like earlier to get y isolated. So I'm going to add 4x to both sides of the equation here. If I add 4x, then we have 7y is equal to 4x plus 4. And then we want to get the coefficient to be 1 for y, so divide both sides by 7. So we're going to get y is equal to 4/7 x plus 4/7. Okay, that would be the equation written in slope-intercept form. The slope here is just going to equal 4/7. That's the coefficient. And for the y-intercept, what we're going to say for that, that's going to be 0, 4/7, just like we did earlier in the last problem, except it's 4/7 instead of -13. Okay, so here, let's really just use the smaller one for the future. Can I fit this? Yeah, I can. Okay, cool. So let's see here. If we want to plot this one, 4/7, let's just say every box here is worth, I don't know, I guess I can say is worth 1. So 4/7 should just be maybe a little bit bigger than halfway through a box here. And then the slope is going to be 4/7. So I got to go up 1, 2, 3. Here, I'll mark it here. 1, 2, 3, 4, and go to the right. 1, 2, 3, 4, 5, 6, and 7. Okay. So if we're going to graph this, it's going to look something roughly like this, where we have a positive slope of 4/7. Alrighty, for number 5, let's take a look at this one. Let's try 12 plus 3y is equal to 9x. Before we even get started for this one, I'm just going to divide everything by 3 from the beginning. That's the GCF for all the terms. So that's going to be 4 plus y is equal to 3x. And then to isolate the y, we can minus 4x, or sorry, just minus 4 from both sides. And then y is equal to 3x minus 4. And then what do we got here? Well, for the slope here, I'm just going to copy over this. The slope here is going to equal positive 3. And then for the y-intercept here, we now know from here that that's going to be 0, -4 from the constant. Okay. In terms of the graph, let's go ahead. Let me steal this real quick. And let's see, we have a y-intercept of -4, so I'm going to go down to -4. Let's say every box is worth 1, so -1, -2, -3. Here's -4, and the slope is going to be 3 to 1. So up 1, 2, 3 over 1, up 3 over 1. And if you go ahead and connect these, there's our graph for the linear equation. Okay, that looks pretty good. Again, just doing a couple rough sketches, nothing too perfect or anything, but give you the right idea of what you're supposed to have. Okay, for this next one, let's try 15 minus 5y plus x is equal to 0. And we need to isolate y, so let's go ahead and add 5y to both sides to get it to the right side by itself. So if we do that, it's going to say 15 plus x is equal to 5y. And so we want 1y, so we're going to divide everything by 5. And I'm going to turn this around and say y is equal to 1/5 x plus 3. Okay, I think it's easier just to write this out. So m is equal to 1/5 here, and then the y-intercept is going to be equal to 0, 3. Okay, that's that constant. So moving over here, how are we going to plot this? Well, 0, 3 is located right over here, and the slope is 1/5. So up 1 and then to the right 1, 2, 3, 4, 5. Or we can also go down 1 to the left 5. 1, 2, 3, 4, 5. All right, so this is a very gradual slope. Not too steep at all, 1-to-5 ratio, and that's what it would look like. Alrighty, moving on. For these next few problems here, I'm going to give an equation, and we're going to find the slope of the line that would be parallel and a slope of the line that would be perpendicular. So for number 7, let's try writing y plus 11 is equal to 3. So let's go ahead and isolate y here, so take away 11 from both sides. So y is going to equal -8. Okay, so we know that this is a horizontal line, so if I asked you to deal with the slope of something that's parallel to it, so for parallel, what's another slope that would have to be parallel to a horizontal line? The slope would have to be 0, right? Because all parallel lines have a slope of 0. And in terms of a perpendicular one, for a perpendicular line, if a horizontal line has a slope of 0, then a vertical line, which is perpendicular to it, has to have an undefined slope. Okay, so very, very important. Parallel line to horizontal still has a slope of 0, but then if you are dealing with a perpendicular one, it would have be a vertical line and have an undefined slope. Vertical lines have an undefined slope. Okay. For number 8, we have this equation x minus 4 is equal to negative 3. To isolate x, we're going to add 4 to both sides of this equation. If we do that, we're going to get x is equal to 1. And so that is a vertical line. So a line that is parallel to it is going to have a slope that is also undefined because the slope of that line is undefined. And this is just kind of like the reverse of the last problem. A perpendicular line to a vertical line means that it would be horizontal and the slope would be 0. Okay, that would be the two types of parallel and perpendicular slopes to the original equation we had. All right, cool. Number 9 here. Let's say we had an equation 11y plus 5x is equal to 14. Okay, so we're going to go ahead and isolate y, take away 5x, take away 5x. And if we do so, we're going to get 11y is equal to negative 5x plus 14. And then to isolate y completely, we're going to divide both sides by 11. And we're going to get y is equal to negative 5/11 x plus 14 over 11. So notice the slope here is negative 5/11. So if you wanted a parallel line to this, what would its slope have to be? Its slope would also have to be negative 5/11. And for a line that is perpendicular to it, the slope would have to be the opposite reciprocal. So it would have to be positive 11 over 5. Okay, so you just have to use the slope and make sure you use the same for the parallel and the opposite reciprocal when we're talking about the perpendicular one. Alrighty, moving on. Let's try a 10th problem here. So for number 10, let's try 13y minus 8x plus 52 is equal to 0. And we're going to isolate the y here. So I think the easiest thing to do maybe, or the quickest thing, is to take away 13y from both sides to get it over to one side by itself. If we do that, I'm just going to turn it around and say negative 13y is equal to negative 8x plus 52. And then let's get the coefficient for y to be 1, so divide everything by negative 13. If we do that, we're going to get 1y, or just y, is equal to positive 8/13 x minus 4. Okay, so the slope here is 8/13. If you want to find the slope of a parallel line to this, then that slope would also be 8/13. But if you were to look for a perpendicular line that would have a slope that is perpendicular to it, that would be negative 13/8. Okay, so one of these has the same slope for parallel, one has the opposite reciprocal. Let's try number 11. Number 11, let's try 14x plus 21y plus 8 is equal to 1. Alrighty, so we need to get y alone. Let's just deal with the constants first here, combine those. So if we do that, we have 14x plus 21y equals negative 7. Now it's in standard form. Let's take away 14x and take away 14x. If we do that, we're going to get 21y is equal to negative 14x minus 7. And dividing both sides by 21, we're going to get y is equal to negative 2/3 x minus 1/3. Okay, so the slope here is negative 2/3. If you have a parallel line to it, the slope of the parallel line would be negative 2/3. And for a perpendicular line, that slope would have to be positive 3/2. All right, one more of these for number 12. Let's take a look at this equation. We have 12 is equal to 34y minus 2x. So we need to isolate y. So I'm going to start by adding 2x to both sides of the equation. And I'm going to turn this around just so we have y's on the left side. I just like them more there. So 34y is equal to 2x plus 12. And then we're going to divide everything by 34. So we have 1y on the left side, or just y. So y is equal to 1/17 x plus 6 over 17. So the slope here is 1/17. So if we were to draw a line that's parallel to it, all parallel lines to this equation must have a slope also of 1/17. And if we have a line that's perpendicular to it, the slope would have to be negative 17, or the opposite reciprocal of it. All right, let's switch gears a little bit again, but let's still talk about parallel and perpendicular lines a bit. So for this next one, I'm going to give two lines here. Let's say that we have y minus 2x is equal to 8. That's one equation. And for a second equation here, let's say we have 2y minus 4x is equal to 5. And the question is, are these lines parallel, or are they perpendicular, or are they neither? Okay, so let's go ahead and see if we can identify their slopes. That's always going to be what you want to do to identify that. So if we add 2x on both sides, we're going to get y is equal to 2x plus 8. So looking on the left side here, we know that m, or the slope, is equal to 2. And for the one on the right, let's go ahead and add 4x and add 4x to both sides here. If we do so, we're going to get 2y is equal to 4x. If we do so, we're going to get 2y is equal to 4x plus 5. And then if we divide everything by 2, we're going to find out that y is equal to 2x plus 5 over 2. So this slope is also 2. Based on that, we can say that these lines are indeed parallel. All right, so they have the same slope, so they are parallel to each other. Okay, that's 13. Here's 14. Let's maybe try another one of these. We have 5x minus 14y plus 12 equals 0. That's one of the equations. The other one here is going to be 10y plus 7x is equal to 6. Okay, same thing as before. Let's see if we can identify the slope. I think the easiest thing to do for this one is get the y's to the other side so that it's by itself. So 14y is equal to 5x plus 12. And then if we go ahead and divide everything by 14, we're going to see here is y is going to equal 5/14 x plus 6/7. Okay. For the other equation, we can go ahead and take away 7x and take away 7x from both sides of the equation. If we go ahead and do so, we're going to get 10y is equal to negative 7x plus 6. And then we can divide everything by 10 here. And if we do that, we're going to get y is equal to negative 7/10 x plus 3/5. So looking at these slopes here, well, on the left here, slope is 5/14. And to the right here, slope is negative 7/10. And those just have nothing to do with each other. So these are neither parallel nor perpendicular. They're just two random lines. All right, for 15, let's try another one. We'll do two more of these. First equation, we have y is equal to 13. Second equation we have is x is equal to 5. Well, this is actually a lot easier than the other one. So this first one on the left, this one is a horizontal line. So we know right away the slope is 0. And to the right, x equals 5, that's a vertical line. So we know the slope for this one is undefined, right? Vertical lines have slopes that are undefined. So if one's a horizontal line and one is a vertical line, these must be perpendicular lines. Long word. I think I spelled it right. If I didn't, sorry. All right, 16. Let's have y is equal to 7x, okay? And for another equation here, we have y is equal to negative 1/7 x. So this one's actually pretty nice as well. So for the left one, the slope is actually 7, or 7 over 1. And to the right side, we have the slope is going to be negative 1/7. So they're definitely reciprocals of each other, and they're opposites. So we know that they are indeed perpendicular to each other. So I'm just going to take that over here because that's a long word to write. So these two lines are indeed perpendicular. All right, just a couple more, but let's try maybe some applications here. So for number 17, just try to listen to the scenario I'm saying here. Let's say you are saving money to buy a guitar, and you are going to put $5 into a jar every single week, and currently you have $40 in the jar. and you do need a total of $129 to buy this guitar. And if we want to write an equation, so maybe for part A, right? If you need to listen to that again, just rewind. For part A, let's write an equation that represents how much money Y you will have in your jar after X weeks. So Y represents all the money you have. And let's see, you're putting $5 every week, so 5 times X, plus the $40 that we already had in the jar. So this would be an equation that represents after X weeks how much money will be in there. Okay, that's going to be part A, where we just wrote an equation here. Now, moving on here, let's go ahead and try B. For part B, let's go ahead and see if we can graph this, okay? So I'm going to go, oops, we don't need this. I thought I was copying and pasting this graph. So give me a second here. Doop. All right, cool. So if we were to graph this thing, right? Let's say everything is gonna go by, let's go by fives. Say 5, 10, or no, that might be a little too much. Let's go like 10, 20, 30, 40. So let's say this is 40 and the slope is 5, right? So the 5 is going to be up 5 over 1. So again, I'm going to say, maybe I should write this down as my units. So 10. So this would be 100 up here and negative 100 down here. And so on the y-axis, I'm going by 100s. I'm going by 10s. So I get up to 100. And then, but along the x-axis, let's just go by normal ones, okay? Because they're going just by week by week by week. So in 1 week, we have $5 more. And then in 2 weeks, that's $5 more. In 3 weeks, it's $5 more. All right, so hopefully you're getting the point here that as the weeks go by, you have more and more money saved up here. Okay, so this is what the linear equation would look like. And what's the meaning of the slope and the y-intercept? So the slope here, we can say the slope is going to be 5. That represents the money you're gaining per week. So it's the money per week. So if you're wanting to know what does the 5 represent, the slope, it represents how much money you gain per week. And then for that 40, right, so that's 0, 40, that's like saying before you even get started, starting amount of money, starting money, right? So you already had the $40. You can't be taking that away from yourself. You already have it, so you don't have to worry about it. So it's a constant value here. So this number here is the 40. It's called the Y-intercept, and you're gaining $5 per week as you go. All right, so for part C here, let's ask the question, how many weeks will you need to save for the guitar? Well, okay, we have the equation y is equal to 5x plus 40, and y represents the price of guitar. So we're gonna substitute this in. The guitar costs $129, right? So the question is like, okay, well, how many weeks go by until you save that up? So we can go ahead and take away 40 from both sides here, because you already have $40, so you don't need to save that. If you do 129 minus 40, that's gonna be $89 is what you still need, okay? And if you get $5 a week, let's see how many weeks it'll take to get there. I think that would be, 17.8 weeks, if I did that correctly. So to be exact, you could say that you would need 17.8 weeks, but you more realistically can just say that you would need 18 weeks to get there, right? After 18 weeks, you would reach your goal to buy that guitar. Now, suppose we add one more layer onto this and say that 8 weeks ago, we had written an equation to represent how much money that we would need to have, that we would have in the jar after X weeks. That equation would be looking a little different. So let's say there's a part D here, and let's say that we started counting 8 weeks prior. Let's say if 8 weeks prior, that means that 8 times 5, the $5 per week, that you wouldn't have that $40, right? So then you just have y is equal to 5x. So this is if like you didn't have the $40. If you went back in time 8 weeks, then you wouldn't have this, right? So this would be the equation if we went back in time 8 weeks. If that's the case though, that means you would be starting from nothing, right? And then each week you'd end up increasing by $5 as you go. And so if you take a look at this equation actually, and this graph, you're going to notice that it's actually parallel to it, and that's kind of interesting, right? So the only difference is you don't have the $40 to start with, and it's just going to take you 8 more weeks to reach your goal. So it's kind of interesting to see here that these two lines would be parallel to each other. They would be parallel, and that's true because the rate of which you're making money is the same. It's still $5 per week, okay? And it would just take 8 extra weeks. So if you didn't have those 8 weeks of money, then you'd have to wait 8 longer weeks, eight more weeks to get that total amount of money. All right, so for 18, we'll do just 2 more problems here. Let's say we have line A. We have line A, and I tell you that it's going to pass the points 0, 8, and it's also going to go through 3, 3. All right, and then we have line B, a second line, and this one is going to go through 0, 4, but we also know it's going to be perpendicular to line A. Okay, so we're going to see if we can write an equation for line B here. All right, so real quick for line A, let's go ahead and find the slope. So slope is going to be the difference of the y, so 8 minus 3 is going to be 5, and then 0 minus 3 is going to be negative 3. So the slope for line A is going to be negative 5/3, all right? And also, actually, if we look at this 0, 8, that's actually the y-intercept. So I think we actually know our equation for line A is y is equal to this negative 5/3 x, right? And then plus 8. So this is line A's equation, right? And we knew the 8 was the y-intercept because the y-intercept always occurs when x equals 0. Okay, so that's line A. Now, as for line B has to have an opposite reciprocal slope, right? So if we take this negative 5/3, and we have to say that this slope for the perpendicular line is going to equal positive 3/5, right? Then we just need to be able to say here that y is equal to 3/5 x plus 4. Now, how do we know that the y-intercept was plus 4? Well, again, if 0, 8 was the y-intercept earlier, then 0, 4 is going to be another y-intercept here. So that's our b value. So this would be the equation for line B, and they would be perpendicular, or line B would be perpendicular to line A because their slopes are opposite reciprocals. And finally, one last problem, number 19. Let's say we have line C. I'm going to write line C here. Is going to pass through the 2 points, let's say 3, 7, and it's also going to go through 7, 13. This is a little bit more annoying just because they don't give us the y-intercept, not as nice. And then line D is going to be parallel to it, but we know it's going to go through 0, negative 4. And that's pretty nice for us because that is the y-intercept. So it's going to be parallel. Okay, so for line C, let's find the slope. What's the difference of the y? 7 minus 13 is going to be negative 6. And then 3 minus 7 is going to be negative 4. So negative 6 over negative 4 is just positive 3 over 2. And so what do we have to do here? Well, actually, we don't need to find the whole equation for line C because they don't ask us for that. We just need to steal this slope and make sure when we use draw the parallel line or write the equation for line D that it has the same slope here, right? This slope also has to be positive 3 over 2 if for line C and line D to be parallel to each other, okay? If that's the case, we can go ahead and write the equation for line D right away because this 0, negative 4 actually is the y-intercept. So we can go ahead and write over here that y is equal to 3/2 times x and then minus 4. This would be the equation of a line for line D that is parallel to line C but goes through the point 0, negative 4. All right, so this was the equation we were looking for number 18. And this is the equation we were looking for number 19. So yes, these questions are definitely a little bit more advanced in terms of if you're in a pre-algebra class. In pre-algebra, you mainly talk about the constant and then rates of change and then just like the general equations for linear equations. But here we talked more specifically about slope and focused on parallel and perpendicular lines. So hopefully you found this helpful, and good luck, and I will see you in the next one.